Hello, the future of our country. This is Mr. Singh from INDRAMATI Education Private Limited, that is providing the best home tutoring services across the Mumbai. Now online services also, online teaching services also. Today we're going to learn about circular motion. This is the first chapter in HSC board class 12th. It is quite crucial topic regarding your exam, whether you are preparing for board exams, IIT, CET, NEET, any competitive exams. So let's begin. Firstly I will zoom it that you can see the whiteboard. Circular motion is just like linear motion, but it's in a circular path. When a particle or a point moving in a circular path is called circular motion. For the example, you can take the fan on your ceiling, or suppose you are moving around a circle in a ground. Suppose you are jogging around a ground. Okay, let me draw it. Y-X, this is the radius vector, or you can say the radius of the circle, the radius of the ground also. Suppose this is initial point A and you move in a circular path A to the final point B, and this is the path traveled by you. Suppose this is S, it is called arc. And now whenever we talk about circular motion, then whenever there is a motion, there will be displacement. In linear motion there is linear displacement, in angular motion there is angular displacement, that is called theta. Angular displacement. So what is angular displacement? Angular displacement can be defined as the angle described by the radius vector on the circle. Suppose you traveled from A to B, then it will make an angle theta by the radius vector. Okay, if this arc, this length is so small, then we can consider it as a straight line. So if S is so small, then we can say delta theta is equal to S upon R, or S, the arc length, is equal to delta theta R. Okay, then whenever there is displacement, there will be velocity, and in this case there will be angular velocity. So what is angular velocity? The definition of angular velocity is the time rate of changing limiting angular displacement. Why I did say limiting? Because it's instantaneous, it's so small, so we are taking it for a small sector. Limit delta t tends to 0, this is limiting. Delta t tends to 0 means it's instantaneous. It's sorry, my mic falls on. Okay, limiting delta t tends to 0 means it's instantaneous. It's for the fraction of second, it's instantaneous. Okay, limiting delta theta upon delta t, or you can also say d theta, it's a vector quantity on t. Now after the angular velocity there will be angular acceleration. So what is angular acceleration? Angular acceleration will be the limiting rate change of angular velocity, obviously, like the linear motion. Limiting delta t tends to 0 instantaneously, delta t, or omega, the angular velocity, the final angular velocity minus the initial angular velocity upon the time minus the angular time. No, sorry, the time minus the initial time. Now, so let's go to d omega upon dt, or omega upon t in the simpler term.